All right, guys. Fuel pump update for the Kia Stinger. I believe Genesis G70 and the G80 have similar systems. We're going to call this Fuel Pump Update 2.0. Now, a lot of you know the last time we talked about this, we were talking about this shuttle valve right here that went inside the fuel pump transfer. We're going to call this transfer T. It's not exactly a T, but it is a transfer system. So I was modifying this. See if I can focus on that a little bit better. I was modifying this and the hole openings inside of this. I also started modifying the fuel pump discharge opening because that is 4.5, 4.6 millimeters. And the fuel line and supply hose and stuff like that, when we checked, it was almost 5 millimeter. So we know there's some room there. But that's not the problem. Here's the problem, is that we are running into basket capacity. So you see the capacity here? This whole entire fuel pump fits down inside of here. And the basket capacity is filled via, sorry, I just dropped the pump. Okay, I'll just ignore you for right now, I guess. Okay. Basket capacity is what the fuel can be sucked through this, got to get a little pointy thing, this little diaphragm right here, okay? That diaphragm is ran through here, where it opens that up through an ejector T system, where it generates a vacuum or a suction. Let that fall out. With this, okay? So this cream-colored ejector T system seals right down here in this lip. Seals right down here in this lip, okay? So this generates a vacuum under here, pulls this open, sucks fuel through the ejector T system, pumps it into the bottom of the basket. The basket fills up with fuel. Okay, we're not running into a high pressure feed line supply. What I was able to see in the operational system and function of the low pressure pump is we were running out of what looked like we were running low on low pressure pump pressure. Okay, so we were going to put a larger pump in here, do a whole bunch of additional work fitting something in there. Come to find out is it was the basket is getting sucked dry. We cannot fill this basket fast enough when you start getting around 500-ish horsepower. The CPI guys traditionally see fuel pressure crash once they start going over like 21, 22 pounds of boost pressure. They start consuming enough fuel. If you're just CPI and you don't have any methanol, you do start to see the the fuel pressure is starting to crash, and you have to start short shifting the car. A lot of these guys with CPI will short shift before 6,000 RPM because this basket is getting sucked dry. Solution, okay? As you can see, I got a bunch of parts laying out here. I've been going through and I've been looking and trying to figure out how we're going to make this fill up faster. Okay, so here's what we've tried so far. Okay, so this hose here is a transfer hose from the other side of the tank. Now the tank is a double hump system where it has one side that fills up with fuel and the other side fills up with fuel. And as the fuel level starts to go down, this system here is constantly drawing in fuel from the other side of the fuel tank. I don't know if it's driver or passenger side, so you have to excuse me there. This system here works on an ejector system where it runs a high pressure jet of fuel down through this hose, which generates a vacuum suction on this hose, which goes over to the other side of the tank. It ejects the fuel out of the bottom of this, which dumps the fuel right here into the basket, okay? What we found is that this system here can be upgraded fairly easy. I've got a new ejector T and I got an entire bag of ejector T's over here. The problem being is the orifice diameters that you're dealing with in this ejector T system are tens of thousandths of an inch. The factory ejector T is 20 thousandths of an inch. I used a probe gauge set. So when we found that out, we started messing with the ejector T sizes. The ejector T, effectively, what it will do is if you increase the ejector T size of this will put a higher volume of suction here. The higher volume of suction transfers into more volume getting transferred over to the fill port here, which fills the basket. I know, kind of confusing, right? I'm kind of dancing all over the place here because we got two systems that fill this basket. We got the suction side that fills the basket from the opposing side of the fuel tank, which dumps the fuel out right here. Then we have the ejector T system here, which creates a vacuum here, which opens this flap, this orange colored flap in the bottom of the basket, which allows fuel to fill up and the fuel gets sucked in and ejected into the basket here, okay? This basket, when you're full, when you have a full tank, it's about 3/4 of a tank. Once you start to go below 3/4 of the tank, the fuel tank level itself no longer, it matches the height, okay? So when you're at about 3/4 of a tank of fuel, the fuel starts to land right about here. At a half a tank, you're, about here. What that means is that this basket has to be filled with the ejector T system and with the ejector T and with the suction system that works off the ejector T system also, that opens up the bottom of the flapper on the basket, okay? We need to put more fuel in the basket when you get below 3/4 of a tank. So, how are we going to do this? Well, there's a couple of different ways. This ejector T system here that has a fuel line that goes up to the fuel pump, and it goes up to this adapter, okay? This hose hooks up to that nipple. It's fuel pressure that gets driven across the, ejector T system, thus sucking, putting more volume, etc., etc. So we're like, well, we can open up this system. We can make it bigger. Actually, you can't open it up very much. So what we did is we increased the diameter of this because there's a obviously thick wall. Sorry, focus isn't really working, but there's a thick wall inside of this fuel pump. We can open this up to about 7 millimeter. 8 millimeter gets probably questionable, but you could probably go 8 millimeter if you wanted to. That seemed to help. Now, the other thing that helped in the last video, we talked about this little shuttle valve. Okay, these holes. So I'm going to turn it around. As you can see, we've modified. Give me a second. Come on, focus. Focus. There we go. As you can see, we've modified that single hole. So we've done a couple of these where we've modified this. This allows more fuel to go into the fuel filter, into the fuel rail, up to the GDI pump. This wasn't per se helping this ejector T system to fill this side to put more volume inside of the fuel system. However, there is a spring behind this, and that spring pushes down on this valve and forces this valve down on top of this. By forcing the valve down on top of here with the spring, we were able to generate more pressure here, but more pressure here equaled more, less volume going to the rail and blah, 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 blah. So we decided to open up this. It seemed to give us 200 RPM of additional fuel before we saw fuel crash that caused early shifting. So we no longer have to shift it, 5,800 to 6,100, depending on your CPI and your vehicle configuration. We're running 6,000 RPM on E60 with this modification without any problems. So since we've been able to get away with modifying this and picking up an additional 200 RPM is what it looks like to be about 200 RPM, that was a good increase in volume into the tank. We're suspecting it's coming from this ejector T because the fuel pump sits like this. And obviously the ejector T system is right here. And we have got the shuttle valve that sits right there. Okay. So opening up the fuel pump, increase the volume into this system, increase the volume to there, it gives us a little bit more. What we need to increase is we need to increase the secondary system for filling from the other side of the tank. we've been successful with this. We've been successful in increasing this shuttle valve system, this ejector T system. Sorry, the shuttle valve's over here. The ejector T system that runs down through this, you see how it's a tapered cone right here? And there's a high pressure jet that squirts down into the top of here. Well, that generates, as that goes down, it generates a suction on this side. Again, this, when it's drawing fuel from the other side of the tank, it's dumping fuel directly into the basket when it's drawing it on this side. This system is pretty much a closed system. Again, we talked about the fuel coming from here, which runs over, goes down to this ejector T. This ejector T feeds across to this. It fills this with fuel. This injects fuel down into the transfer port from the other side of the tank, blah, 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 blah. More or less, if we increase the supply to this hose, we should, and we do, end up with more volume being drawn in from the other side of the tank and filling the basket. We're at like 11 minutes worth of just random bullshit talking, and this may not make sense. Not being able to see the system in operation, not being able to see how the system functions, maybe honestly, having two ejector T systems inside of a single supply line, I'm going to be honest with you, seems like a kind of a broken system. Volkswagen, Audi, they don't do that. They literally put a pump. They put a line directly into the top of the pump. The pump pressurizes the whole entire system for the ejector T system. In the Kia Hyundai, they decided to use a transfer T with a shuttle valve. The shuttle valve controls, how much pressure is driven through this and across the dual ejector T system, blah, blah, blah. The thing being is what we've done by opening up the top of the fuel pump, by increasing the holes in the shuttle valve, and then modifying the ejector T orifice here, we were able to get, I think we're at 6,400, 6,500 now, and we don't have any fuel crash. So going through and doing all the modifications to the fuel pump and making, instead of, there's a couple bastardized systems out there on the market where you have to go through and chop up your fuel pump housing, you got to shove a Volkswagen pump in there. It's just a huge mess. It's a shit show. The other thing is that, we don't want to chop this all up. We want to take what we have that is factory. We know that works. The pump moves quite a bit of fuel volume. The last test I think we had when we were testing at the upgraded voltage, because I think it ramps the voltage up to 14.4 volts with the fuel pump module, 14.2, and when it ramps the voltage up, we're looking at 320, 325 liters per hour out of this pump. The pump does move quite a bit of fuel. So the factory fuel pump should be capable of 560 to 580 horsepower if we can get rid of all the restrictions. However, I don't know if the basket is going to be capable of filling that request. Again, all of your fuel is drawn in through here and sucked in through the other side of the tank. Obviously, this system here is maxed out. We can't pull in more fuel through this system. So we have to resort to drawing in more fuel from the other side of the tank. Now, the whole idea behind drawing in fuel from the other side of the tank is it keeps one side full all the time. Keeping that side full all the time means you have a full level over here. Fuel can spill over the edge and you don't have to worry about the basket running dry. However, hard acceleration, you start to see hard acceleration where all the fuel slosh will move to the back of the tank, or left-right where you have fuel that'll slosh over to the other side of the tank. In autocross or track days, you need to have a system that will keep this basket essentially full. I think that doing the modifications to the T, the top of the fuel pump, the shuttle valve, and modifying the ejector T for the draw from the other side of the tank might be enough for us to be capable to make about 600 horsepower. Again, we're running E60 at roughly, actually I think we're running E55, somewhere in there, E50 to E60. and we are running CPI, and we're not running into any crash issues at about 6,400 RPM with this being modified. Now, the other thing we could do, and I did give it a try. I wasn't happy with the results because we did run into some issues due to the suction on the bottom of the tank. So, factory fuel pump has a pickup point, right? Obviously, it picks up all of its fuel from the bottom of the fuel pump here. So this fuel pump is drawing in fuel from the bottom of the basket. So, and the fuel pump sits roughly right here in this opening. So we thought it would be a good idea to go through and just cut a hole in the bottom of this, where it sits on the bottom of the tank, and the fuel pump can draw from the bottom of the tank all the time. It doesn't have to worry about the basket running dry. That actually worked really well until the car got below a third of a tank. Once the car started getting to below a third of a tank, obviously the basket, fuel, obviously we didn't cut it, an exactly perfect hole that fit in, because that doesn't actually protrude through the bottom. We cut a hole in the general area and location of the suction side of the fuel pump. When we cut that in the bottom of the tank, about a third of a tank, the tank would slosh. Fuel would slosh away. It'd pull away from the pickup point in the bottom of the tank. And essentially the fuel would just leak out of the basket. It couldn't pull any fuel from the basket anymore. And that created a situation where we have to tell customers if they wanted this to happen, if they wanted to go with that, you would be stuck with always having to have a third of a tank of fuel in your car if you wanted to race your car. Not an ideal solution, but nonetheless a solution. Guys with full-blown hangers, full-blown fuel system hangers, shout out to you guys. The full-blown fuel system hangers essentially delete the baskets, hang a couple fuel pumps with a shroud inside your fuel tank, and it's a great system. It puts 2 pickups tubes right on the bottom of the tank, but however, when the fuel tank does slosh, the pumps go dry because they're not sitting in a basket. So like on most full-blown systems, if you don't have a basket built into them and the pumps are just sitting in the tank, you are going to see fuel pressure drop off, fuel pressure slosh, and your pumps are going to run dry every time you get on it and you're below a quarter of a tank. I have a full-blown system in my SRT4, and anytime I got below a quarter of a tank, the pumps would dry, fuel system would essentially vapor lock, go to zero, and the car would essentially shut down. So my SRT4 Neon always has to be over half tank if I want to keep the system happy. Under full throttle. Again, full throttle is the only time you're going to run into a problem with a dual hanger system inside of your fuel tank with double pumps or big single pump and no basket. So the whole idea behind a basket is to keep the fuel pump constantly submerged in fuel, so you don't have to, you can have the slosh and stuff like that, hence why they have the pickup, hence why they have the transfer tube from the other side, etc., etc. So what's this mean, guys? Well, this means that a new ejector tee, modifications to the shuttle valve, opening up the fuel pump to a roughly, like I said, you can go 8 millimeter. We don't. We go like 7.2 millimeter when we open these up. And modifying the ejector tee system for the draw from the other side of the tank seems to be working. So we want to make sure that people know that there is a solution. You can probably get away with running E85 up to like 460, 485 horsepower with some fuel pump modifications. The GDI pump is going to be the next problem. We are making a fuel line, so we did find that there's some inconsistencies across the different model years with the poly fuel line. With the quick connects, there's some neck down points inside of the fuel line, some tight radius bends and stuff like that we were seeing inside diameters collapsing down to like 4.2 millimeter. I believe that right at the fuel pump, at the connection point that comes up from the firewall, there's a connector right there, and I believe that connector almost necked down to 4 millimeter. So we do know that there's some issues with the fuel line. Putting the fuel line on the car did net quite a bit of volume, and actually we saw fuel trim correction move about 6%, 5 to 6% when we just put the fuel line on the car. So we know that the fuel line is putting more volume at the GDI pump, and the GDI pump tone does change when you put a high flow fuel line on there. We are running 6AN line on the shop test car, and the 6AN line seemed to have given us some additional volume via fuel trim adjustment. What does this mean? Again, like I said, I just kind of rambled on about this system. This means that I will be testing some of these different fuel systems. I'm going to be testing the ejector tee. We're going to be opening up a little bit more, see if there's a diminishing returns. But right now, we know we have something that is fairly reliable, and I have to figure out how to get this system put together for you guys so we can go through and make a system that is ready for everybody to use. I can't go through. I don't want to buy used fuel pumps. I want to buy brand new fuel pumps. So what we think we're going to do is we're going to put together a brand new fuel pump with fuel line with auto modifications done to the fuel pump, and we're going to offer this as a complete assembly for doing low pressure fuel pump upgrades. I will have some customer feedback on this particular fuel pump, and I'll try to get some logs posted up for you guys and show you the benefits that we're seeing with the increase in fuel line and different modifications we've done to the fuel pump. So I'm hoping that this made some sense. If you watched out to the 21 minutes that we've been recording for, I appreciate it. But I do hope that in showing how the system works with the double ejector system, how it pulls from the other side of the tank, how it pulls a vacuum / suction from the bottom of the tank through the little diaphragm, and how when you go over, or when your fuel levels drop below 2/3 of a tank, you do start to run into some slosh issues, and the basket will eventually get sucked dry by the fuel system because there is not a fuel spill. And again, you're not getting fuel spill over the edge of the basket when it's sitting inside the fuel tank. And as the fuel level runs down the side of the basket is your only remaining volume for the engine to be provided under full throttle. All right, guys. I need you guys to let me know what you want to see changed. You need to tell me what you didn't get from this video, because I can go through and do some more videos and I'm trying to explain this a little bit better. But this is, kind of the breakdown of what we've done to the fuel pump and what we have plans of making in the future readily available for you guys. Thanks again for watching, guys. I hope this was informational. Again, any questions you have, please put them in the comments under the video so I can see what I need to change inside the next video when we do finally release the fuel pump. Thanks again, guys.